So, hello everyone, and I welcome you to our today's webinar with the topic using EtherCAT with B-Nimis, BCPi, and Raspberry OS. Let's jump right in. A short overview of our agenda. There is a short introduction about me, the speaker, and about Berkoff automation and control solutions. And then we go straight to the topic, EtherCAT on B-Nimis BCPi. What are my options if I want to realize EtherCAT on the B-Nimis BCPi? What do I need and how to set it up? And after going through these points, I will provide a short showcase how I follow my steps that I will show previously and initialize an EtherCAT communication. Okay, let's go. Introduction. My name is Konstantinos Arabatsis. I joined Berkoff in 2012 as an application engineer for CODESYS V2 and V3. In 2015, I made the jump to the technical support of the Berkoff automation and control solutions. Additionally, I am also a trainer for CODESYS V2 and V3, as well as our products or how to use our products and how to develop on them. Additionally, in the support, I provide support for all Berkoff controllers for CODESYS V2 and V3, and also for our PowerTrack devices for the rail-mounted guiding system, as well as how to realize remote access to our PLCs. About the Berkoff automation and control solutions, we are a system provider for demanding control tasks in plant engineering and worldwide equipment. Berkoff specializes in customized solutions based on a highly flexible standard portfolio, combining maximum fulfillment of requirements with maximum qualitative product safety. The hardware and software components impress with their sophisticated functions and maximum reliability, even under extreme loads. So, these are our main industrial branches. We are in the classical industry and machine building. So handling machines, sorting machines, packaging machines, and sort of. We are present in intralogistics with our PowerTrack devices. Basically, we have a specialized control system for rail-guided vehicles based on our SC CAN, which is a grinding CAN communication. And we are present in the building automations, mainly in air and climate control. Yes. Let's get on with our topic, EtherCAT on B-Nimis BCPi with Raspberry OS. What are my options? So, if I have a BCPi, the device shown here, I am not working directly with the MCPi, which is a PLC, but I have a small industrial PC running Raspberry OS. So, and one of our features that we have on our devices is the right-sided port, where we can extend the module with additional I/O modules for different parts, digital I/O, analog I/O, communication I/O, for I/O extension. And this port can be used via the EtherCAT. So what can I do if I want to use them? I still have the option to use EtherCAT via the CODESYS control for Raspberry Pi. So I can just download the CODESYS extension for my Raspberry Pi and realize it with CODESYS and using it as a PLC. This is a very, the easy solution, because everything is as is and provided. I have a graphical interface where I can just do the setup. I can add my modules, and after that I can work with it. And the second option, if I don't want to use CODESYS control, I'm not a PLC programmer, I don't want to invest the time in that, I can go with the simple open EtherCAT master, which is an open source EtherCAT master stack, which is easy to use and provides a small footprint. It is available on GitHub in C and Python. Very important to note is that it is licensed via GPL. So if anyone plans to use it professionally, he has to comply with the GPL licensing. It has a simple application layer, reference-based object locking, and ability to send and receive Ethernet frames. It has a statically allocated memory. It supports EtherCAT features like COE, CAN over EtherCAT, FOE, file over EtherCAT, EOE, and also SOE, and also distributed clocks. If I have devices that support distributed clock configuration, are also supported. In this example, in this webinar, we are going further with the SOEM or the SOEM, and I will show how you can set it up. One additional info is that if you want to use EtherCAT bus on your BCPi and you plan lower cycle times than 10 milliseconds, it is recommended to install a real-time patch on your Raspberry OS. Just like to improve performance and so that you can go lower with the cycles. It is difficult. It's important to note that the performance on the Raspberry OS, even with a real-time patch, will not be the same as our dedicated MC-Pi controllers that have a special customized real-time Linux running on them. So what do I need? First, of course, I need a B-Nimis BCPi Pro or a BCPi Prime. Here are just some technical overviews. There are 3 variants which differentiate in size of integrated RAM and flash. We have a 1 GB version with 8 GB flash, a 2 GB RAM version with 8 GB flash, and a 4 GB version with 32 GB flash. The 2 later variants will also have the option for Wi-Fi and Bluetooth. I support the EtherCAT master bus. We are third-party suppliers. I have an integrated display interface. I have USB 2 and USB 3. I have a JST connector for a cooling fan. I have integrated real-time clock, and I can also mount an extended heatsink for better cooling, some of these features. And the same goes with our BCPi Prime, our double module, which has the same exact variants with different RAM and flash sizes. Additionally, you have a 2-port Ethernet switch here, which is a separate Ethernet interface, and I have 2 more USB connections on this device. Otherwise, they are more or less the same about the features, just more interfaces. So what will I also need? I will need a B-Nimis MC-IO module. 1, 2, 3, 4 depends on the use case. And for this example, I will use a B-Nimis DCIO 1616 with 16 digital in and 16 digital out. And last but not least, I will need the SOEM stack. To get access to the SOEM stack, basically, I will need a B-Nimis BCPi, sorry, with internet access so that I can download the SOEM directly on the BCPi. And also, I will need to download the CMake tool command for the B-Nimis BCPi so that I can build the stack and translate it on the Raspberry so that I can get it to work. So this is all I need. of course, we have the power supply and the wiring, but let's go to our setup. So our setup is done via 3 different steps. First is we need to prepare the B-Nimis BCPi. So let's go step by step. I take my BCPi here and I connect my I/O module. Oh. Now it's connected, and I power it on, and now I have to wait a little until it is powered on. After it has boot up, I access the BCPi with the preferred method. So in this case, later I will open a VNC client onto the BCPi and see the desktop, and I will work with the integrated Linux console. So after I open the Linux console, if I want to, I can give this instance of the console with the command sudo su and a permanent root access as long as this is open. If I have a non-unconfigured device, I will have to start up the ETH1, the Ethernet interface 1, which in this case is my EtherCAT interface. And also, I will need to install the cmake command with apt-get install cmake. apt-get install cmake is a common command. With this, it will access, if I have an internet connection, of course, an internal database from the Raspberry Foundation, and the cmake is in there. It will download it automatically and install it, and basically that's done. I say here optional because it depends. In my case, the cmake is already installed, and then I can download the SOEM, the SOEM with wget, the command, and the download link. The download link is not written out here, but it's basically the download link from the GitHub page of the archive that is for Linux. After I have downloaded it, I can extract the SOEM with the command tar xzf and then the file name that I have downloaded. And this is basically the first part. So I booted up and accessed my BCPi. I prepared and downloaded every software that I need. And then I go to the next step, which is to build and translate the SOEM for our system. So I enter the extracted SOEM directory. You will see it later. And inside there, I have a README file, which shows me a short overview of the next steps that I have to take. I open this file with cat readme.md, and then I just follow the commands in the README file. First, I have to create a new folder with make-dir build and cd build to access it. Inside there, I execute the command cmake ... and then, if I'm finished with that, a make, and then the SOEM stack will be translated and built, so we will be able to run it on our Raspberry Pi. If that is also prepared, the last step is to test and to run the EtherCAT. The SOEM comes with some example applications. One of them is the slave info, which reads out the EtherCAT interface and provides information about the devices that are connected to it. So this is hidden, yes, in a subdirectory of the build. So I enter the subdirectory with my commands, and I go to build test Linux slave info, and then I execute the program with .//slave-info eth1. This is the interface that I opened earlier, and it will read out the information of the devices. Is everything done correctly? It will show the device information of the found slaves, and I know that my EtherCAT is functional. So from here, there is also an included simple test project, which can be used as a base for your own EtherCAT project. So I will show the code a little bit later, but we have prepared here for this setup a small simple test BGH for Berkoff, which just is reading and writing and showcasing some of the IOs. So I have now here, let's go to the showcase. So I jump here and I connect via the VNC client to my Raspberry. And the first thing I do is I open my terminal. So what I can do now first is type in sudo so that I can change to a root access. I will not do it in this in this case because the user based console has different color distinctions and it's easier to read for you. So for here, I will just execute commands with root access. For this, I just type in sudo, and the first thing that I will do is I will start up my Ethernet interface, though that it is up and running. And then if I type in ls, it lists me all the files that are now in my Pi home, in the root folder, basically, of the PLC, of the Raspberry Pi. And I can see here that I have already downloaded the archive of the SOEM. And so the next thing that I will need to do is to extract it. I type in xcar, xzf, and then b. And by tab, I can create an autocomplete with the matching string. And I press enter. And if I now list again, I can see here there is a new folder with my SOEM, and I will access this folder. And if I list again, here I can see here my readme.md, which I will open. And if I read my the text file, I can see here the extractions under the Linux section, which I need to do for the rest. And also it says also here that I will need the cmake command already installed on my PC. So let's go. First, I say make dir build. This just creates a new subfolder, make dir, not make dir, but build. I can see it here, and I access the build subfolder, and then I just follow the commands. I type in cmake ... and it precompiles, and then I just type in make inside the same folder. And now it is building my SOEM and basically making it ready to use. So if I type in again ls, I can see here my test folder, and I go in and say cd test, and then I go cd linux, And then if I type in ls, these are my 3 now built example projects. And I access to slave info. And here, if I go ls, I see here with the green that I have an executable, and I need to execute this now. So I type in sudo, I need root access because I will make him use the ETH1. So, and then I say slave info. And I say here ETH1 and I press enter. Okay. I have to write slave correctly. And now it read out the information. And what I see here, it says it's running slave info. I have an EC init on ETH1 is succeeded, and I found 2 slaves. The first slave is the onboard bus coupler that is running on the BCPI itself. And the second slave is my DIO 1616 module, and otherwise it gives me a little bit more information. What is my output size? What is my input size? A delay and some more information about that. So with this now I know, okay, my EtherCAT is running and functional. I'm fine. And now I have to leave this folder because I need to go and work now with our Berkoff example. And if I see here, I have a folder simple test BGH. And I will say now here test simple test BGH. And if I look inside here, I have a C file and I have to translate this first 2. So I will go here sudo make. And it created now the file. And if I do another ls, I see here that I have now the executable for the simple test. And again, I go with sudo dot slash and simple test. And again, ETH1, because I have to tell him which interface he has to use. I start. And now I get another information here. I have the simple test with Berghoff EIO modules. I have 2 slaves found. I have an information about the slaves that have been found and that they are all operational. And what I can see here is that I can have just a simple bit shift. And I always set an output every cycle. And I read in the input, which you can have here. I can show it also. I hope you can see it with the light that is going from up to down. And now I have a working EtherCAT. Of course, I can extend this simple project to more modules. This is just like a simple showcase. Now with Control C, I end the project, and now I'm stopping my EtherCAT. So for anyone that is a little bit used to CODESYS and how the CODESYS EtherCAT master works, or how a lot of PLC IDEs work, is that you normally need how to say, a device description file. For EtherCAT, it's mainly an XML file, which has the device description inside. And first you install this device description in your PLC IDE, and then you can use the EtherCAT modules. The SOEM works a little bit differently. What it does here is it reads out the EtherCAT bus dynamically and gets all the information it needs from the slaves directly and initializes them. and gives you the info needed so that you can access to the output and the input size. So basically, if I go now to the C file, which I will just do a quick showcase on what we changed on this simple test, so that it will run with our with our devices. It's the only thing that we need to know is how much are the input sizes and the output sizes of our different modules that I'm planning to use. So if I jump back here, nope. Where is the file? One moment. It's here. Sorry. You can see it here. And I will just open it with an editor. And I will just go a little bit through again. So this is the simple test file that comes with the SOEM when I download it. And we have only made some slight changes. So we were working with a standard, and if you know a little bit of C, it's not very difficult. So these are some standard definitions that are done, and basically everything is commented. You start with the EC init. The EC init is a function that comes from outside of the SOEM stack. And what I do here is I scan and I config all my slaves, and then I wait for all of my slaves to read to reach the safe op state, and I change them to operational state. And with here, I send one PDO and I receive one PDO to check if the connection is there. And if this is done, basically I print the information about the modules that are found, and I go to my op mode. So everything that you have seen here up till now, until here, is default simple EtherCAT master, and our changes basically start from here. So we wait if all slaves are in operational state, and after that we go inside and we check here for our setup, are there two modules found, and is the second module of my EtherCAT modules with 16 in and 16 out. This way I know that this is the correct module inside. You could also use further information like the module name and things like that. This is just a small showcase. This is how we can check if the correct modules are there. Otherwise, printf that the EBUS configuration is wrong, so not the correct module is there. And after that, I will have my small cyclic loop where I do some bit shifting on my slave 2. I have my slave 1, slave 2. You could also use what you see here, slave 0. Slave 0 basically means all slave. So what is doing here, it says wait that all slaves are in EC state operational. And basically that's it. Here I do the bit shifting, which you could see, so that every cycle the active bit jump to the next. And I do this every 50 cycle, otherwise it would be too fast. Here I send out my data and I receive my data. And this whole part here is just the printing that was shown, how the bits were shifted inside the console. So no functionality, just like a showcase. Otherwise, here we would be done with how I access my IOs. After that, I have a sleep, which is my 10 millisecond cycle. And after that, it's everything again, simple test, default. I just check if my modules are there or not. The cyclic background check and slave monitoring, that I go here with a slave count, so I know how much slaves are in there. I start at slave 1 and then I check everything. And even like with checking, and if I remove the slave module, it will restart it again automatically. And that's basically it. So easy to understand. The simple test code has everything you need to get started and to work with the EtherCAT. And basically, you just need to extend it with the information that you want and extend error handling and just making changes that are akin to your use case. Otherwise, we are at the end of our presentation. Thank you again for joining us today. And if you have any questions, feel free to contact us, either me, the technical support, or one of our sales managers, Mr. Macias Geisler or Mr. Rafael Wall. And I wish you a nice afternoon. Bye.